I'm going to be doing a review today. And what we're going to be looking at, we're just preparing for the exam for next week. And let me take a look at the schedule real quick. Disappear here. All right. So what we have is we have the exam on Monday. Now I need to get a hold of my colleagues and just sort of verify. Let me write a note real quick. Just, we're all kind of on the same page. And, are they doing, how are they going to handle notes, if there are going to be any notes allowed. So make that note. So I need to confer with them to sort of verify what we're going to do. I'll let you know as soon as I can find out. So today what I'm going to do, we're not going to cover any new material. So I'm just going to go over some problems that, things that could show up on the exam. Now, again, the idea of a review, it's not to replace studying. If you just do the review and then take the exam, you could be in for a bad surprise. It's to get started. So I just want to kind of kickstart everyone in that direction. So so hopefully this will help. And again, what I emphasize with this is do practice problems, list problems that were really tricky or difficult, and then work on those. And this is going to be the story problems exam. This is where we have those sections there on these story problems. So getting comfortable with those could help a lot. So try to practice with those. We'll do some today. And the methods that we studied for the story problems, like the box method, how to come up with a box to help you solve the problem, that could be a very helpful thing. So I'm just going to pick some problems starting in section 2.1. And in section 2.1, we're solving for x. Now, what ultimately happens is the skills we use in 2.1, we're going to use in the story problem section when we design our own equations, and then we have to solve them. We get a better pen. So we're going to solve for x. So it might have been a while, but one of the things we need to do, we have a minus sign outside parentheses. Is we're going to distribute that minus sign. So this will give us minus x. Minus and minus become plus. Then plus 2x. Minus 8 equals 4. Again, distribution is what we use to get rid of parentheses. By the way, how's everyone doing this morning? Oh, good. Well, well, hang in there. We got a test coming up that will try to get you prepared for it. Again, I recommend practice problems. Again, on this test, try to do the easier problems first, harder problems last, so you get as many points as you can. Try to study early, or try to get started studying as early as you can, just to kind of make things easier on Sunday night. That's just sort of something that helps. Taking care of future self, in other words. So now we got to combine like terms. So we have x terms, negative 1x. Negative x is the same as negative 1x. A positive 2x. So negative 1 plus 2 gives you 1, or x, single x. 7 and negative 8 is negative 1. And that's equal to 4. Add 1 to both sides. we'll get x is equal to 5. Questions about that? So let me pick out another one. So let's see. Got that one. Let's do this one. Ooh, take a step back here. So we've got parentheses again. That means we want to get rid of them. We got to distribute. So we're going to distribute the 3. We're also going to distribute the minus sign in front of it. So when you distribute a number, you're going to take the sign with it. Now, if this is a plus sign, I'm just distributing positive 3, and pluses really, they don't change anything. But with a minus, things will change. So 3 times 6 is 18. Negative and negative is going to be positive. 4y minus 3y. You have 1y. 18 plus 2. We're going to get something like that. Subtract 20 from both sides. Yeah, y is negative 12. So questions about that? All right. Let's see. Now let's say we have something like this. Now, this type of problem, what I'd recommend first is try to combine like terms. So 2 minus 16, that's going to be negative 14. So what we can do here, if we combine these, now we can eliminate the fractions if you want. And I'll be honest, that's sometimes an easier thing to do. In fact, let's do that. Let's just make it easier to get rid of fractions. And I'll do this problem starting from here again where we don't do that. So 1/4 y plus 1/3 y. What does that come out to? Well, if we can find a number that's divisible by 4 and also divisible by 3. I mean by divisible, if you divide by 4 or if you divide by 3, in either division, you won't get a remainder. And a number that does this, well, there's a bunch of numbers, like 24 will do this, 36 will do this. A number that's kind of easy to work with that will do this, 12. Because 12 divided by 4 gives you 3, and there's no remainder. Also, 12 divided by 3 is 4, and there's no remainder. So we're just going to let n be 12. So that means we're going to take this equation, multiply both sides by 12. Now, if we do that, that means we're going to distribute 12. Let's see, 144 plus 24, negative 168. So what happens here, 12 times a fourth. Another way you can think of this, remember, a fraction is the same as division. 12 times 1/4 is the same as 12 divided by 4. Same thing for 12 times a third. They're going to mean the same thing. So you could just calculate 12 times a fourth. That's totally fine. But we can treat it as division. Either way, you're going to get 3. Here, either way, you're going to get 4. So you're going to get 3y plus 4y minus 168. Combine like terms. Let me see. That is divisible by 7. So if you divide that by 7, you should get negative 24. So any questions about that? Now I want to show you how to do this if we don't multiply through by 12. And for this particular problem, it'll work out. We can add the fractions. Now to add the fractions, they need to have common denominator. So take 1/4 y there's some number we can turn 4 into. We could also turn 3 into that same number. And again, a good candidate is 12. So to turn 4 into 12, multiply by 3. Then what you do to the bottom, you got to do to the top. To turn 3 into 12, multiply by 4. What you did to the bottom, you got to do to the top. Now we can add these. Oh, I'm sorry, this is 12. Same denominators, we can add these fractions. We'll get 7, 3 plus 4. Keep that common denominator of 12. We still have 1. Now at this point, we'll rewrite this up here. At this point, there's a couple ways you could do this. One way is, since you have 7/12 times y, is to divide both sides by 7/12. So you have -14 divided by 7/12. Now, to do this, we're going to make 14 into an improper fraction, or 14/1. And then we do our KFC. Keep this, flip this, change that to multiplication. Again, with fraction multiplication, we multiply horizontally across. Again, we get 24. Oh, this is a -14. I forgot my negative. So that's using what we know about fraction division. We can divide both sides by that fraction. We'll still get the same answer. Another way we can take this on, though, is we can, when you're dealing with fractions and you want to get rid of them, you can multiply both sides by the reciprocal of the fraction. So the reciprocal means you just flip it. So you multiply by the flipped version of the fraction. And again, what you do to one side, you've got to do to the other. These will cancel. That's the power of reciprocals. Again, make 14 or -14 an improper fraction. do the problem that way also. Questions about that? Let's see, there's a certain kind of problem I'm looking for here. There we go. Now, let's take a look at this. Again, we've got parentheses, so we want to distribute. If you got a number with a minus sign, you're going to distribute the minus sign also. So we could combine like terms on this side. 8 and -2. We could add 2 to both sides. Add 6x to both sides. Numbers on one side, x is on the other. What we're going to get, though, is -6x plus 6x. That's 0. And this is bad news. What this means is this equation is, sometimes they'll say, malformed or something to that effect. And this means we don't have a solution. We get a result like this, where the x's cancel out, and we have something that doesn't make any sense, like 0 equal to 8. 0 is not equal to 8. We have no solution. So this could come up on a test. Something to keep in mind. Now let's say it's something like this. Again, to get rid of parentheses, we're going to distribute. So if we do that, 8x plus 12 equals 8x plus 12. We got the same thing on the left as you do on the right. So, I mean, if you could continue trying to solve it, you do that. You're always going to have the same thing on the left as you do on the right. Try to get all the x's to one side. Now, in this result, we don't get nonsense. Last time we had gotten nonsense. We had some claim that 0 was equal to 8, which isn't true. But this is true. 0 does equal 0. And so when you get this kind of result, the answer is all real numbers. Or in XYZ, I think what they sometimes have you do is put OO. Not 0, 0, but OO as a stand-in for the infinity sign. So you can get a couple unusual results that way. Questions about that? All right. One more from this section. There. So again, we're going to distribute the 10. Now I got a plus here, but with a plus, we don't really worry about it. Plus 10 or just 10, they're the same thing. Plus 10, positive 10, plain 10. They're all positive. So distributing 10, well, maybe if you want to, you could say we're distributing the plus 10, but we're going to get the same result as distributing 10. Again, we can combine like terms. Divide by 15. Let's see, 165 divided by 15. Let me grab a calculator for that real quick. You're going to get, excuse me, 11. So any questions about that? So in section 2.4, we're getting in the formulas. We have formulas and percent problems. So the idea with formulas So the idea is we want to get this capital T by itself. So to get T by itself, we want to remove all the other variables. And what we do is we treat T as if it's the only variable. And we treat these like they're numbers. Well, I mean, they are numbers. They're just unknown numbers. But we're going to move them around. So canceling C on this side, pretty easy, subtract C. But what we do to one side, we have to do to the other. So you got to subtract C from the other side. Now, because we don't know what D minus C is, we just leave it. We say, well, all right, that's the best we can do. And that's it. That's our answer. Now, any questions about that? So let me do a trickier one. So here we're going to solve for V. Well, we want to get V by itself. So taking a look. Just like with equations where we solve for x, we've got V multiplied by something, but then we also have this other term that's added or subtracted. Well, in equations where we solve for x, we cancel the term that's added or subtracted first, then we deal with the thing that's multiplied to V. So we want to cancel this entire piece there. So we'll do this. We'll add the entire piece to both sides. Since we don't know what h plus 16t squared becomes, we just leave it. That's totally fine. Finally, we've got to divide off that t, the opposite of multiplying by t. So we divide that side by t. We also divide this entire side by t. So it looks like we're just dividing a single term here, and we actually are, but this term is really the entire side. When we divide by a number, we're actually dividing entire sides. So when you do the division, it doesn't hurt to remind yourself that if you're going to divide the entire right side by t, you better divide the entire left side by t. By coincidence, the right side happens to be only one term. So it looks like we're just picking and choosing when we're really not. This entire side and this entire side. So when you divide this entire side by t, well, here's the entire left side divided by t. Remember, fractions are the same as division. And that's our answer. Questions about that? So for percent problems, there's different ways of doing this. One of the things is translations. So let me do an example. So what number? Well, that's an unknown number. We can call that x. Is equals. Now 25%, we can represent this as a decimal. That's 0.25. Of means multiply. So if we do our translations, we'll get x equals 0.25 times 40. Where x is equal to 10. So that's one way of doing this problem. There's also another way. What number is 25% of 40? Well, we can think of this as part, base, and whole, or part, base, and percent. So for the part, there's a number that's 25% of 40. So if you're a percent of 40, you're part of 40. But they didn't tell us what that number was. So that's unknown. Now, the base, if we're taking 25% of 40, we're taking something out of 40. So we start with 40, we take something out of it. So 40 is going to be our base. And then our percent, well, that's 25. So what we can do is we can use this equation. Part over base equals the percent over 100. And the formula always starts out like this. The 100 is always there. So we don't know part, so it stays P. It's unknown. Base is 40. There's the percent. And 100. Solve for P. We can cross multiply. Divide both sides by 100. We get the part, that unknown number is equal to 10. Let's do another one. So what percent of 40 is 14? Well, again, when we talk about what percent, that's something that's unknown. So we can call that x of multiply is equals. So this means x times 40 is equal. Oh, switch my pins here. X times 40 equals 14. Or another way of putting it, 40x is 14. So we solve for x. Let's see, 14 divided by 40, 35 hundredths. Now we gotta be careful though. When we solve for x like this, and x is a percent, what this means, this is the decimal representation of the percent. So we gotta take this decimal because if you put this in your answer, you'll get it wrong. You have to convert the decimal to a percent. So if you use translation like this, you got to be careful. Remember how in the other translation problem, we took the percent and we converted it to a decimal? Here we got a decimal, we got to turn it into a percent. So you got to be careful with that. You see a numerical percent, it's got to become a decimal. If you're solving for a percent, you're going to get a decimal, you've got to convert it to a percent. The way you do that, move your decimal and that's going to be your answer. Questions about that? Now let's take a look at this again. Let's use the formula. So what percent of 40 is 14? Well, right away they have what percent. So that means the percent's unknown. Now you're taking, again, a percent of 40. You're taking a chunk out of it. And that means you're starting with 40. So that means the base is going to be 40. And then basically by process of elimination, the part's going to be 14. Or if there's some percent of 40 or some part of 40, what is that part? It's 14. So now we use our formula. Again, we cross multiply. Divide both sides by 40. We get R is 35. Now the advantage with the formula, when we use the formula in the before, We had that 25%. We didn't convert it to a decimal. We kept it as a percent. And then when we use the formula and solve for a percent, we get the percent in the percent form. So we don't have to convert anything here if you use the formula. If you use the formula, you can just keep the percents the way they are. Finally, 16 is 50% of what number? So let's do translation. Is equals 50%. Again, when we're using the translation method, we've got to convert the percents into decimals. Multiply. Unknown number, the variable x. So what we get is 16 equals 0.50 times x, or 16 is 0.50x, or 0.5. You don't have to put 0.5 and then the 0. Solve for x. We'll get 32. Questions about that? All right. So 16 is 50% of what number? So if we use the formula approach, well, the percent's given. That's going to be 50. 16 is 50% of something. So that means it's part of something. So that's going to tell us that the part is 16. And then 50% of something, that means we start with something and we take 50% out of it. So what we start with is going to be our base. So the base is unknown. So we plug in what we know and leave what we don't know. Cross multiply. Divide both sides by 50. And sure enough, we'll get a base of 32. So again, you have options when you do percent problems. You can use the translation method, or what you can use is the formula method. It just, the thing with the translation method, you got to be careful. When you have a percent in the problem, convert the percent to a decimal. So like if 25% shows up in the problem, you have to convert it or translate it to 0.25. But if you're solving for a percent, what will happen is you'll get a decimal answer. Like the unknown percent is 0.35. You have to convert that to a percent. That means move your decimal 2 spots to the right, and you'll get your answer. You got to be careful with that. Like let's say we had x equals, for solving for a percent, x is an unknown percent. To make it into a percent, you move the decimal only 2 spots to the right, and you would get 35.2%. So sometimes there is a decimal still in your percent. All right, so looking at section 2.5, you have these number problems. So let's say you have this. So we're trying to find this mystery number. And they use a 4 or 6-step process to do this. And I'm going to do the first 4 steps, where the last 2 you're checking to see if your answer makes sense. 5 times the difference of twice a number and 6 is -20. Find the number. So what do we know and what do we not know? So what do we have? Well, this is kind of a tricky thing. Let's see. For this, what can we actually speak to? Now, in terms of known, with this kind of problem, I kind of picked a hard one. There's a good reason for that. What we know are numbers. Now, there's relationships between these numbers, and we can get into that a little, well, not really relationships, but we do have the numbers themselves. So let's just list the numbers that we know. Well, there's a 5. There's a twice. There's a 6. And there's a -20. So what we know is we have some numbers here. Now, there is sort of some relating that's going on. We're going to figure that out in step 2. But what are the hard facts? Well, there's a 5, there's a 2, there's a 6, and there's a -20. What's unknown? Well, there's a number. There's some mystery number. So what we're going to do in step 2, and the way we try to understand what's going on, is we identify what is known, and then we identify what is unknown. There's this mystery number. So for step 2, we can call a number x. So that's what we have. Now, what we can do in step 2 is we can start translating. So we've figured out the numbers that are known and the number that's not known. We understood that in step 1, and then in step 2, we take this unknown number, we call it x. So we're actually starting to translate. So let's do some translations. 5 times the difference of twice a number and 6. Now, first off, something to keep in mind with this type of problem, 5 times the difference. So this is going to be 5. This is going to be times. And then the difference. So what that means, we're going to put parentheses. Because a difference is one number subtracting another, or it's one thing subtracting another thing. So we're going to take this entire subtraction and multiply it by 5. So it's going to be 5 times. Now what's doing the subtracting? Well, we know a number is x. Twice actually means 2 times. So the difference we're talking about is 5 times 2 times x and 6. So the difference, and we'll do this in stages. So far, we're going to have 5 times the difference of 2x and 6. Now, the difference of 2x and 6, I want to make sure we've got parentheses on that, because it's 5 times that difference. It's not going to be 5 times the 2x or the 6. It's times the difference of 2x and 6. So what that's going to give us or so we can translate that. Now, I'm going to try to come up with an equation. And when I do that, that's usually when they say we're in step 3. So if you want, you can just translate this whole thing. Don't worry about getting into steps. Just know that when you have something times a difference or something times the sum, that means you're getting parentheses. So what we have is 5 times 2x minus 6 is negative 20. So to finish the translation, that's really what we're doing. So again, you don't have to be so formal in step 2 and step 3. Is equals negative 20. Look like that. Finally, for step 4, we solve our equation. So we distribute the 5. So we get x equals 4. And again, steps 5 and 6, does the answer make sense? If you is 5 times the difference of twice 4 and 6 equal to negative 20? Does that actually work? Just checking your answer. I want to do another one. Let's see. I'm going to do this one with a more translation approach. So let's say we have this. So one number is 3 less than a number. Their sum is 15. Find the numbers. Well, what do we know? Well, we have a 3. We have a 15. Now, what do we not know? Well, there's this one number. And then there's this another. So for this type of problem, it helps to identify that you have 2 things that are unknown instead of 1. So let's let the one number equal x and the another equal y. Now I'm just going to jump to step 3. And what I'm going to do is I'm just going to translate this thing all the way through. So translating this. Well, the one number we called x. And then here's is. Again, is equals. Another number we called y. Now, at this point, we might want to update things because 3 less than y that's going to be y minus 3. There's some. Well, if we add one number with another number, that's x plus y. Is equals. So putting it all together, if x equals, and then y minus 3. And then we have this, x plus y is 15. So we get 2 equations out of this. So for 4, what we're going to do, we'll take x plus y equals 15. And we're told x has this alternative identity. So we'll replace x with y minus 3. Combine the y's. Add 3 to both sides. Divide both sides by 2. So we get y is equal to 9. Now you want to remember, we're not done. We still have to solve for x. So remember, x was y minus 3, or 9 minus 3. Or in this case, x is going to be 6. Questions about that? So we've got about 4 minutes left. I think I can do one age problem, and then that'll be it for class. I'll continue the review in lab, and I'll record it in lab as well. So let's say we have this. So John is 4 times as old as Martha. 5 years ago, the sum of their ages was 50. How old are they now? Well, we're running out of time. We won't be able to do this in less than 3 minutes. So I'm going to hold off on this to the lab. So what we'll do for 2.5, we'll have an age problem, a perimeter problem, a coin problem, and then we'll move on to 2.6. But we'll come back to this during lab, which will start in about 17 minutes. So any questions about this, let me know. Other than that, I'll see you in lab, and I'll record the lab as well. And what I'm going to do with the recordings, I'll post those. I can send those out. So if you have to miss the lab for some reason, you'll still be able to see the review part of it. So other than that, I'll see you in about 16 minutes.